Okay, so this is a study about capitalized value of urban vegetation waterway renewal in Singapore housing market. Oh, okay. Okay, Singapore is a tropical island, but not like that. It is densely populated city-state, abundant rainfall, but water is scarce because there's not enough land to collect the water, and because of lack of aquifers and lakes. So this is how populated it is. It's about 70% of Auckland size, but population is about 4 times more than Auckland. It has a lot of rainfall, 3,000 millimeters at places, a lot of waterways, but these waterways are canals which are designed to get rid of water. And not much concern for livability or beauty or whatever, or clean water. And maybe 14 years ago in 2006, government of Singapore launched a program which is called Active Beautiful Clean Waters. And this program does many things. Some of the things would be to design, guideline, training, certification for implementing different environmentally sustainable green features for waterways. And other element is to build specific or implement specific projects like canal renewals, reservoirs renewals, rain gardens. So active, beautiful, clean waters. Active means it promotes physical activity, recreation. Beautiful means that they want to provide some amenity, and clean, you have to have clean water if you want to have first and second. So there are about 30 projects out of 100 planned being implemented by 2018, and they spent 140 million of Singapore dollars on these projects as far as specific projects. And so this is map of some of these projects, or most of them. And then Bishan Park, the kind of biggest one and most interesting, is behind me at the moment. Very nice park. And about 15 of the projects are canal upgradings, which means that they have this canal which is drain, which is concrete, and they want to make them nice and beautiful, and people just enjoy them and having physical activity. And there are other projects like enhancement reservoirs or rain gardens and some smaller things. And I will be talking about canals. So here are examples of what they do with canals, and then there is Alexander Canal on the left, what was before, what was after. Another canal is on the right, what was before, what was after. So clearly they become nice and beautiful and encourage physical activity contrary to what was before. So the question is, does enhancing and improving canals with greenery in the creation space provide amenity to urban residents? And then how far does this amenity extend spatially? Like, does it go for, do people who live about like 500 kilometers, 5 kilometers from canals still get this benefit? And then do benefits to residents outweigh cost of undertaking these projects? So these are questions. Why do we ask them? Because it's useful to, if you know this information, it's useful to plan new similar projects, or maybe justify what had been done. As far as whether research was done on these topics before, yes, people did, or scientists did study, did use mostly hedonic modeling to look at the value of waterway renewals, but mostly studies were cross-sectional, so didn't compare before and after. There are several cross-sectional studies, but as far as our knowledge, no studies estimated non-market value of canal restoration in densely populated urban environment like Singapore. That might be relevant to other similar densely populated cities. So we will decided to use hedonic pricing method. So we use home prices so that we could use home prices to value this environmental amenities. We know that in hedonic pricing method, the assumption is that the house price, or home price, or apartment price is reflected by characteristics of this house, and also by the, you see that bigger house costs more money, and also like if there are some amenities next to house, it's value incorporated in that value of house. But if this amenity is not good, then we have even this amenity. Okay, so we want to use this approach. So a few words about housing market. So majority of housing stock in Singapore built by government agency, which is known as Housing Development Board, HDB. And but 80% of population live in these flats. They kind of own them. But bad news is that there is no free market for new HDB flat, despite they buy them, they are distributed. On the other hand, there is active, a good resale market for HDB flat. If you live in it for 5 years, a new one you can resell. So, and there is huge amount of data. We got about 773,000 transactions from 90 to 2019 in 8,700 HDB blocks. Blocks would be like high rise. And it's all the apartments or flats in that block are similar in sense. These are locations of those blocks, HDB blocks, and of the water sensitive sites or ABC sites, which we want to value, and light green are canals. So we will use difference in different hedonic model because, okay, you could see that there are numbers, these are years where canal were upgraded, 2016, 2010, 2018, 2016, 10, 15. So we have years. We could have look at the values of the houses before and after. So our dependent variable will be a log of price of apartment, and we'll have covariates, which is a description of the apartments or flats. That would be area, type, story, block renovation. So some of the blocks are renovated regularly, and that impact price if you want to use difference in difference approach. Proximity to MRT stations, they build new public transport stations, and this construction could influence the value. Also, we use year and quarter interacted with planning area fixed effect. Planning area is like suburb, to take into account that there could be some temporal trends, or definitely there are, and the trends could be different in different suburbs. Also use block fixed effects, means that we will take care of everything which is spatially related to the block, all the apartments or flats which are located in the same block. Okay, and these are variables of interest. So D, capital D is whether this apartment or flat is treated, kind of, whether it's located within certain distance from the project. And capital A is a after treatment variable, which tells whether this flat sold after the nearest project was completed. Okay, so we have this D and we have this A, and then we have interaction, and this interaction is if treated apartment, apartment in treatment group was treated. So it should capture this effect of the renovation, and lambda is our coefficient which are interested. And like, yeah, I mentioned that there is year and quarter fixed effects, and there is block fixed effects. So they will make these two variables redundant, so we get rid of them. Oh, this is a model. Okay, we have a lot. I told we have a lot of data, and a pitfall of using a lot of data without discrimination could result in different unexpected and wrong results. So we saw that we would do some selection. We selected blocks within 2 kilometers from canals, which are upgraded, and we selected only canals which are completed before 2016 to make sure there is enough time after. We picked transaction 5 years before, 5 years after completion of nearest canal, and you see that the different canals complete in different times, so they are kind of heterogeneous in that sense. And we got about 53,000 transactions. Also, to make sure that we are not picking something like trend of apartment within canal, we did falsification test, which is we kind of made up date of the completion 10 years before. You remember we had data from 1990. So we falsified data and have like another data set, which is pretend renovation of canals, same the canals. And we get another data set, and we just wanted to see if there will be a similar effect in that. We get 62,000 observations in that data set. So these are the results. So red dots would be base model, which is true model, and light red would be, so dark red would be 500 meters, which is one band. We assume that effect is 500 meters from the canal, and light red would be three 250-meter bands, 250 to 500, and 500 to 750, and blue, dark blue and light blue would be falsification test, similar specification. I show here only the variable of interest. On the x-axis, we will have the effect of the canal, the value of the lambda coefficient, and on the y-axis, we have different variables. So look at first this base model with three bands. We see that within 250 meters, 250 to 500, the value increased by about 1.5%, and from 500 to 750, there is no impact. Looked at just 500 meters, about similar impact, about 1.4%. Falsification test, if we have three bands, we see that neither of those bands pick up any impact of the canal, of fake, so to say, renovation. 500 meters, no impact. So we kind of sure that impact is extend to about 500 meters, and that we actually picking up true impact of the renovation of the canals. Okay, so this is all. But we wanted to go more. We wanted to do another specification. We use difference in different exact match estimator. So for that, we selected treated apartment or flats and matched them with apartment in the treatment group before treatment, and with another two apartments which are outside of this buffer, which is in non-treatment group before and after. So we imagine there are two blocks. One is closed, one is not closed. This is treatment group, this is control group. This is treatment apartment treated. Okay, and then we matched this treatment apartment with four apartments. One in the same block before treatment with the same characteristics. So the same time treated in treatment and control group in the same time, and before treatment in the same time, and characteristic like story, flat type, and other characteristics are similar. Okay, so we have this matching, and then we can use just only matched apartments to see what is the effect. Again, we did same thing. For the base case, for true model, we estimated that impact of this upgrade would be 1.8%, significant. And for our falsification test, there is no significant impact. So we kind of sure that what we got is confirmed by using another method. So our benefit, how can we calculate? We have about 81,000 flats in 500 meters, and the value of them is $37,000, $37 billion in 2016 prices. We assume that improvement was 1.4%, between 0.8 to 2%, 95% confidence interval. So the benefit of assuming these numbers, the benefit would be $529 million, and compared to budget $140 million, clearly these projects provide benefit which outweigh the cost of the implementing of these projects. And finally, conclusion. Estimated benefits of canal upgrading is greater than cost. Cost evaluation is important to promote these projects and to analyze impact. and limitation is only benefit capitalized in the housing market are valued. And this method is only applicable if we have houses or apartments or flats next to canal. Thank you very much.